Bismillahirrahmanirrahim. Friends, up till now we have learned how to model, analyze and design a simple RC beam in MIDAS GEN in our previous videos. Further, we have learned how to check the adequacy of RC beam having any reinforcement. From today, we will work on reinforced concrete portal frame analysis and design in MIDAS GEN. This is our exercise number 4. The problem statement says, analyze and design a reinforced concrete portal frame having beam size of 250 by 450 mm and length of 6.5 meter and column size of 250 by 250 mm and height of 8 meter. Both columns are fixed at bottom. Loadings are on beam as follows. UDL as dead load of 3 kN per meter and UDL as live load of 6 kN per meter. Point load as dead is 10 kN and point load as live is 15 kN. These point loads are to be applied at mid of the beam. The material properties are as follows. Compressive strength of concrete is 28 MPa equivalent to 4000 psi and yield strength of rebars is 414 MPa equivalent to 60,000 psi. So let's get into the software screen. So previously we have modeled a beam using point grids. Now we will model our frame using line grids. So to define the line grids, just go to the structure tab, click on the grids and define line grids. Just go to add, give any name, let's grid 1. And an X grid lines, just go to add and put it. Since our beam is having the span length of 6.5 meters, so just go to 6.5. Okay. We just required only grid in X, but we can't leave the grids in Y as empty, so just add and any number, let's say 1 meter. Okay, and click on OK and apply. Now this is the line grid that we have created. Now go to the node and element tab, just click on the create element button. Since we did not assign any material properties or section properties, so just leave it as it is and just go to this point and click here and click here and just press escape. Go to the view tab and click on the grids and turn off the line grid. So this is the beam that we have just created now. Okay, so this is the beam. So for the column, we'll have to extrude these points to the negative Z direction. Alright, so just go to the nodes and element tabs again and click on the extrude button. Just select these 2 points, these 2 nodes. Here it is written extrude type node to elements. There are different kinds of options for extrude. We can extrude node to element, we can extrude line to planar elements, we can extrude planar to solid elements. So for the time being, we'll just select the nodes to line element. Just leave other options as well. Just go to the translation option and we can see equal distance and click DZ minus 8. Since we have the column height as 8 meter, number of times 1, the nodes we have selected, then click apply, click close. Alright, so this is the frame that we have modeled. Now we will give them a properties. So go to the properties tab, add material, add and just go to concrete ASTM RC. Let's say 4000 and click on apply. We can just shuffle to the section properties from here as well. Just go to the add button, set rectangular, user, and so for the beam section we are having the section of 250 by 450, so 0.45 0.25 here, name B 250 by 450. Right, and then click on apply. Okay, Since we just click on the apply section, so it has applied this section to all the lines that we have created. But we don't want this. We want the another section applied for the columns. So we'll go to the copy button. We just copy this section, just modify it, name it as, since we are having the column of 250 by 250, so column 250 by 250, 0.25, 0.25, and click on OK. Now I will show you an amazing feature of MIDAS GEN, is that just go to the Works tab. Under this Works tab, the complete detail of structure is here. Structure having 4 nodes, having 3 elements, having 3 beams. The structure type, the line type is beam, right? The material type is C4000. And this particular sections are 2. There are 2 sections. One is beam and the other one is column. The section that have been assigned to any line is showing with the black font, and the section that did not have assigned to any line is shown with the blue color, right? So we want this section to be assigned as a column. So just select single button, select the columns, and just select this property, click the mouse button and drag it, so it's applied. Right? This feature of MIDAS GEN is very useful when there are lots of beams and columns in your model, so it's a quite useful thing. Okay, so just go to this hidden button so that we can see our model in a single line. Now for defining the supports, just go to the boundary tab, click on the define supports. I want these 2 points as the fixed supports, so just click on this D all, R all, and uncheck it RW. It's a warping degree of freedom. We don't want to apply it. Just select these 2 nodes and click on apply. Okay. So in this way, the fixed support has been applied to both of these nodes. Now we'll go to the loads tab and go to the static load cases. Since we have only 2 loads, dead and live, so first dead, type is dead, add, type is live, add. Alright, just close it. Now we want the self weight to be applied, so -1 factor in the Z, add, OK. Now go to the elements button, element loads, go to the dead. Since we are having the dead load of 3 kN, so -3 in Z direction, relative, just select this beam, apply, and for the live load we are having 6 kN, -6, click apply, OK. Now we are having the 2 point loads as well for the mid of the beam. One point load is the dead load having 10 kN and the other one is the live load having 15 kN. There are the 2 ways to apply the point loads. The one way is to break this beam into 2. So a node will be created here and we'll go to the nodal loads and apply that load. But if we don't want to break the beam, so just go to the element tab and click the load type options. We can see there are the different types of loads: concentrated forces, concentrated moments, uniform loadings, uniform moments, torsion, trapezoidal loads, all the other types of loads. So just go to the concentrated forces. So these are the point loads we want to apply. So we'll have to select the dead load. Since we are having the dead point load of 10 kN at the mid of this beam length is 6.5 meters. So just click on the absolute button and 6.5 divided by 2 is 3.25 and the load is -10 kN. The beam has been selected, just go to apply. So this is the load that has been applied. Click on the live load case. The distance is same, but the loading is 15. So just minus 15. Select the beam and apply. Alright. So in this way we have applied the loadings. We can see the magnitude of these loadings that we have applied it correctly or not. Just go to the works tree menu, just go to the static load case. We can see element beam loads under the dead load. Just click it and right click display. Point load is minus 10 and the UDL is minus 3. Live is minus 6 UDL and minus 15 is point load. So it is okay. Now go to this, right click and undisplay. Now the loadings have been applied. Now go to the structure tab. Just go to the structure type. Since this is only a 2D frame in XZ plane, so we'll have to select XZ. Okay. Now I will show you how to incorporate the stiffness factors for the columns and beams. So just go to the properties tab and click on the scale factors. So the dialog box appears. Now we want the stiffness factors for beam as 0.35 for the moment of inertia. Since the beams are having the cross-sectional dimensions of y and z, so just go to IYY 0.35, IZZ 0.35 and add. Similarly for column is IY 0.7, IZ 0.7 and add. Alright. So section stiffness scale factors have been applied. Just close it and now go to the analysis tab and perform analysis. Since your MIDAS job is successfully completed, the message has been displayed here. So just we can go to the results tab and see the support reactions like reaction under the dead loads, apply. So these are the reactions. So for showing the values, just click on the value and OK. So these are the values of the support reactions. Alright, it is only showing now the forces. Just click on the Fx. So it is showing the forces in along the X, reactions along the X direction. Forces in Y, there is no forces in Y because we have modeled this frame as a 2D in XZ plane. FZ, these are only showing the reaction in Z directions. FXYZ is now showing all the forces only. To show the moments, just go to MX. There is no MX moment. MY, yes, there is an MY moment. We can just go to this button, arrow button, isometric view. We can see the directions of this moment. MZ moment, click on this. The MZ, there is no induced moment. MZ, MX, YZ, click apply. Only MX is showing. Alright. Just go to the deformations and displacement contours. Under the dead loads, dx, y, z, contours apply. This is the contours. Just animate it. Apply the record button. So it is now animating. With the contours, just go to legends. In the fixed form, 6 decimal places, let's say, and OK. So this is showing the legends corresponding to the displacements here. Okay, and we can also see the beam diagrams under the dead loads, let's say moments. That's why just solid fill it. To show on a bigger font, just go to the display option, click on the elements and go to the element output value and increase the font size as 10. Apply. Okay. Alright, so we can see the form shape. Just go to the quick view and just select any element. Just select this one, so we can see this under the live, under the dead. Okay, by clicking anywhere we can see the value and the position. Just click on this beam, we can see the results under the live, under the dead. Right. Okay, so in this way we can analyze the frame. Now just design it by going to design tab, definition of frame, just raised XZ. Since we are now having the column, so just check it, this option, auto calculate effective length factors. Okay, and we want it to be checked on ACI 31811, let's say, and the design code, just okay, and modify concrete material, just select this button, and ASTM-RC, just go to select the grade 60 for both and modify. Okay, click on the rebar criteria. We want the rebar, let's say, of 12 mm for beam, 12 or 16, both we can use, whatever the software want to apply. And stood up 10 mm arrangement 2, sidebars we don't want, sidebars let's say 10 mm for beam, the cover is 40 mm, uncheck the doubly. Consider spacing limit for the columns, we want only the 16 mm dia bars. Okay, and the ties are of 10 mm dia, arrangement 2, Y and 2Z. The O is cover for the column, just 40 for this as well. And that's it. Click on OK. We have to define the load combinations. Just go to the results tab, loads combinations, concrete, auto generation, ACI 318, strength level, strength. OK. Close. Now go to the design, perform mesh design analysis, concrete and column design. Now these are the two dialog boxes, one for the beam and one for the column. Right, just go to the members and members. Since there is only one member having the beam property and there are two members having the column properties. Okay, just decided. Now check on the connect models and select this. So this will highlight this, that this particular section is assigned to this column, this member, this line, and this is assigned to this. So we can check it in detail. Just go to the graphics and we can see all the results associated with this column design. Okay, it is okay, it is showing okay. And similarly for the beam design, it is now designing the beam having 12 mm dia bars. Alright, so in this way we can check this. We can also check the details. We can see all the calculations for the column design associated to this column. Alright, similarly for the beam we can. So this is up for today. In the next video we will learn how to check the frame for existing reinforcement by modifying the beam and column rebar data. So we'll see you in the next video. Take care.